guys, memory just ran out. We'll start a new video. I did actually finish with all the functions that I've got on the board, and I've added a few more. So I did keep that one. So that was our parabola that was centered around the y-axis. Okay? We did give it the vertical shift to b. In this case, b was positive, and it looks like a was negative. But now from here, what we can do is go to here. What I've done here, I got rid of the vertical shift, so I've put it down onto the x-axis. But what I've done instead, it gave it a horizontal shift. So the x, okay, turned to x minus p. Okay, so now the what do you call it? Keep forgetting that name. Just a second. The turning point. Olivia, you weren't here to remind me. The turning point in this case is not x equals 0. This was the turning point here. The turning point here is p. Okay, when x is equal to p and that is squared, that's your turning point. Okay, so what I've done here is a vertical shift. In this case, p is positive. If I use the negative p, it will move to the left. Okay, the a in this case is obviously negative because of the sad face. So I swap the vertical shift into a horizontal shift. And then the last one, I've added back our vertical shift. Okay, so I took this one, which just had a horizontal shift, and I added, in this case, I think a negative q, so it pulled it down. And I also swapped the a, so I made it now a smiley face, so a is positive here. Okay, and that's your general parabola. If you were to simplify this, open all the brackets, you'll get y equal. I'm going to use different letters now, okay, because I'm not going to start doing algebra here. But that's your general ax squared plus bx plus c. And that's your general parabola, okay? Right, moving on to here. So I told you we'll come back to that circle. Okay, I know it's a little bit bright here, but you can see it's a circle. Now, a circle is not a function because each value of x here has two values of y, and that can't be a function. But that doesn't mean that there is no mathematical relationship that describes this circle. Not a function, but it's a mathematical relationship. Now, what do we know about all these points? Each one of these points has a certain x and a y. Okay? And what do we know about them? Okay, points on a circle. We know that if we take the square of x plus the square of y, the x's can be different. From, let's say, this point and that point, they'll have different x and different y's. But if we square the x and the y, we're always going to get the same value, which is the radius of the circle. So x squared plus y squared equal r squared. Right? So that's a circle centered around the origin. Okay? I can make a big circle, I can make a small circle. Okay? We'll call the big circle R1, and the small circle will have another radius. Okay? We'll call it R2. So each one of these relationships can be described like that. X squared plus y squared equal r squared, where r is some kind of constant. Okay? But it's not a function. However, as we saw before, if I just take the top half of that circle, that semicircle, then that is a function. Okay? How would I describe that function? Okay? Well, when I describe a function, I always want to have y equals something. Oh, sorry, I can't see. Okay? Y equals something. Right? So how would I do it? Okay. Just keep it simple. Right. We're going to say, okay, we're going to move the x to the other side. So we're going to write y squared equal r squared minus x squared. And now we're going to square both sides. So y is going to be equal to the square root of r squared minus x squared. And that is this one. That's the top part of the circle. Okay? Because when I wrote, and we spoke about it earlier, when I wrote the root squared, I really mean I'm looking for the positive root. If that makes sense. If I want to describe the bottom bit of the circle, then that's going to be y equal negative root of r squared minus x squared. Okay? Right? Just to be on the safe side, if let's say y squared plus 9, then I've got really two answers here. I can have y equal 3 or y equal minus 3. So when I just don't write anything in front of the root, I always mean the positive value. If I write the negative in front of the fruit, not the fruit, the root, then obviously I mean the negative sign. Okay, guys? So, okay, we're not finished. Two more. Trig. Okay, you've done trig, you know trig. Okay, so these are what some, I'll call them the mother graphs, okay, of trig. Okay, that's going to be y equal, can you think about that? That's a sine graph. Starts at 0, it's like a wave. Goes up to 1, back to 0 when the angle is 180 degrees. But remember, here we're working with radians, so it goes down to 0 when the theta is pi. Then it goes back to 0 at 2 pi. Okay? Your cosine graph starts at 1, goes down to 0 at half a pi, which is 90 degrees. Carry on going down to minus 1 when theta is equal to pi, and then goes back to 1 at 2 pi. Okay, that's a cosine graph. Obviously, they go to negative and positive angles. I think you should know what is a negative angle. Okay, just counting in the other direction, but let me know if you don't. Okay, I think we teach that in grade 10. And that's it. Okay, obviously we can add an amplitude, increase it, we can do vertical shift, horizontal shift, all that sort of stuff, but maybe we'll deal with that later. Right, I'll pause here. Yeah, and that will be the end of this lesson. We're going to do another lesson. Let's just carry on. No, we'll do a separate lesson after this, after these commercial advertisements. Take care.